Here we have the infinite series of 1 divided by n plus 1 times n plus 2, and we want to show that this infinite series here converges to 1/2, meaning it's equal to 1/2. And so first, what we're going to do is do a partial fraction decomposition of the expression 1 divided by n plus 1 and n plus 2. And so this is the same as some constant dividing by the factor n plus 1 and plus some constant divided by n plus 2. And here we have two fractions and we want to add them so we can cross multiply. So it would be a times n plus 2 and then plus b times n plus 1. And then dividing by the product of n plus 1 times n plus 2. So once again, cross, multiply, and then divide by the product of the two denominators. And so now we have this quotient is equal to this quotient. The two denominators are the same, and therefore the two numerators have to be the same. So we have 1 plus 1 is equal to a times n plus 2 plus b times n plus 1. And this equation here is true for any n. And therefore we want to find what is a and what is b. And so what we can do is this: look at the factor next to the a constant and then find something that will make this factor 0. So we let n be negative 2, and then negative 2 plus 2 is 0. So that's what we're going to do. So we let n be negative 2, then in the place of n we have negative 2, negative 2. Negative 2 plus 2 is 0. 0 times a is 0. Negative 2 plus 1 is negative 1, so we get negative 1b. And so b is negative 1. Multiply both sides by negative 1, then we get b to be negative 1. So we got b to be negative 1, and now we need to figure out what is a. And so to figure out what a is, we look at the factor next to the constant b and think of something that will make this factor 0. And so we can let n be negative 1, because negative 1 plus 1 is 0. So we let n be negative 1, then in the place of n we have negative 1, negative 1. Negative 1 plus 1 is 0. Negative 1 plus 2 is 1. 1 times 8 is 1a. So we get a to be 1. And so now we have 1 over n plus 1 times n plus 2. In the place of a we have 1. In the place of b we have negative 1. And this is the same as 1 over n plus 1 minus 1 over n plus 2. And now we can rewrite the original series. 1 over n plus 1 times n plus 2 is the same as 1 over n plus 1 minus 1 over n plus 2. So this is an infinite series, and now let's find the first 10 terms. So this is the sum of the first 10 terms, and is 0.4166. This is the sum of the first 100 terms, is 0.901. This is the sum of the first 1,000 terms, is 0.499. This is the sum of the first 10,000 terms, is 0.4999. And this is the sum of the first 100,000 terms, is 0.49999. And so it looks like as n gets larger and larger and larger, the sequence of partial sums, these are called partial sums. The sequence of partial sums is approaching 1/2. So that's what it looks like from these numbers. And so we think that so from here, the pattern looks like the limit of s of k as k approaches infinity. This is the sum of the infinite number of terms. Look like this limit here is approaching 1/2. So that's just by looking at these numbers. And now let's go find the sum of the first k terms, and then we can show that the limit of s of k, or the limit or the infinite series, approaches 1/2, converges to 1/2. And so we have used the partial fraction decomposition, and we have shown that 1 over n plus 1 divided by n plus 2 is 1 over n plus 1 minus 1 over n plus 1. And so this is our series right here. And so the first term will be 1/2 minus 1/3. The next term will be 1/3 minus 1/4. The third term will be 1/4 minus 1/5. The fourth term will be 1/5 minus 1/6, and so on. The kth term, then in the place of n, we just have k. The k minus 1 term, then in the place of n, we have k minus 1 and k minus 1. And so this is the sum of the first k terms. This is term number 1, number 2, number 3, number 4, number 5, number 6. And this is the kth terms. And then this is the k minus 1 term. And then from here, we can see that the minus 1/3 and the 1/3 will cancel out. Minus 1/4 and 1/4, and then 1/5 and 1/5, minus 1/6 and 1/6. So all of these will get cancelled out. And then next, we can see from this pattern that this is k minus 1 plus 2, which is k plus 1. And it will cancel out with this one and this one. So the only thing that's left is the 1/2 minus 1 over k plus 2. And therefore the sum of the first k terms is 1/2 minus 1 over k plus 2. And so we have just seen that the sum of the first k terms is 1/2 minus 1 over k plus 2. And therefore the infinite series is the same as the limit of s of k as k approaches infinity, because this is the sum of the infinite number of terms, which is the same as the series itself. But s of k is 1/2 minus 1 over k plus 2. As k approaches infinity, this term will go to 0. We get 1/2 minus 0, which is 1/2. And therefore we have just shown that the infinite series here converges to 1/2.